My name is Andreas Köglmaier. I am part of the German sales team and present this webinar from my home office in Munich. I'm supported by my colleague Sebastian Sielemann. So as I said, this webinar was initially planned to be a wrap-up webinar for the IT Trans. We intended to review the hot topics from the exhibition. As the IT Trans was postponed, we decided to adapt the style of the webinar. Along 10 topics we had prepared to showcase at our exhibition booth. We like to provide you an overview where our software can help public transport and rail planning. With this webinar, we like to address our existing software users and people who not had a chance to work with our software yet. As we provide an overview, we won't go into the technical details. However, we will guide you to other recorded webinars covering certain topics in detail. Well, like us at PTV Germany, probably almost all of the webinar attendees will be affected in one or the other way by COVID-19. Certainly, the pandemic has a very strong impact on the public transport systems around the world. While in this webinar, we won't address specifically how our software could be used to manage the current challenges PT operators and cities are facing related to COVID-19, many of the shown topics can be applied to help with those challenges. It is possible to ask questions during the webinar, so please use the chat functionality for this. We will gather the questions and answer them at the end of the webinar. So to start with, I like to give you a quick overview about PTV. To put it into one sentence, like you read it here, we plan and optimize everything which moves people and goods worldwide. We are a software company focusing on improving transport and mobility around the world. We have over 40 years of experience in this business. Our roots are going back to the Karlsruhe University. With our strong academic background, we are able to bring the latest algorithms for optimizing, simulating, and modeling transport and mobility systems into standard software solutions. Well, what about PTV and public transport? We analyzing, understanding, and optimizing public transport systems has always been one of PTV's core focuses. On the one hand side, we have a very strong public transport consulting business, which has guided our clients through the changing public transport market over the decades. Working very closely with our clients has helped us to better understand their challenges and find solutions for them. On the other hand, our developers had always had a strong focus to find appropriate data models to represent and handle the complexity of public transport systems and develop algorithms modeling the passenger behavior. In particular, our software PTV Visum is known for handling questions related to public transport very well. In this webinar, we will also provide an overview of other PTV software solutions. However, the predominant focus will be on PTV Visum. So PTV Visum combines the view of the passenger with the view of the operator. It is bringing the demand and the supply side of a public transport system together. What this means, I will describe in the following slide. A transport model integrated in PTV Visum replicates basically the behavior and the choices when PTV services changes. Depending on the attractiveness of the system and the alternative option and the choice behavior of the population, the passenger demand can then be calculated with the transport model. Based on the demand, you can determine a timetable and optimize your vehicle scheduling. When you look at your vehicle scheduling, you might find a better timetable to reduce the number in vehicles and therefore reduce your operational cost. So basically, the software allows you to attribute the cost to specific services. By reducing or increasing the number of services, you can then see the impact on the demand. So PTV Visum can help you to balance, so on the one hand side, the impact of the operational optimization to reduce your cost, but also how to improve your system to increase the number of passengers. So it's basically a balance. Once you basically optimize your service quality, have less services. It could happen that then because of the less services, you have less passengers, but it all can be balanced out with Visum. Before we will discuss our 10 key topics, I like to give it now the handover to Sebastian, who will provide you with a general overview on PTV Visum with public transport in a live demo. And I hope it will work now. Sebastian, can you hear me?
Yeah, I can hear good as well.
I give it over to you now.
Okay, can you see my screen?
Yeah.
Yeah, perfect. Sorry for the bumpy start. A warm welcome from my side as well. My name is Sebastian Sielemann. Also working from home office these days, and usually working for a product management team of PTV Visum in PTV headquarters in Karlsruhe. I'm happy to give you some insights about our software solutions and, of course, answering your questions. Yeah, and I would like to start with a short introduction in PTV Visum, so we have all the same starting point for our upcoming discussions. PTV Visum is our macroscopic transportation planning suite, and as such, it depicts the traffic supply and the demand. And so maybe we start with the supply to show you some things here. The classical transportation supply is the network. It consists of nodes and links. And this one here is an example network from the middle of Germany, which is often used in our example. And of course, it contains public transport related elements like stops and lines. But besides this, Visum holds a dedicated public transport model, which allows to model the supply in a more detailed way. There are things like stop points and stop areas, which allows to model transfer and transfer walking distance in much more detailed way. And of course, the supply or contains things like timetable. This is our graphical representation of a timetable, and here you see two lines, a green line and a blue line with selected stops of their journey. You as well see the arrival and the departure times. In addition to this, we have something we called a schematic line diagram. It supplies or visualizes the supply in a schematic manner. If you want to plan your supply, you want to have the stops, the frequencies, and the connections in mind. And this schematic line diagram is summarize all this with the width of the edges. It depicts the frequency of the supply. The figures at the stops represent the arrival or the departure minute of the journeys, and this makes it easy to assess the transfer conditions at each stops. Yeah, so this is short for the supply side, and of course we want to have a look at the demand. And in a macroscopic transportation model, the demand is most times represented in matrices. Our small example here contains of 90 zones, so we have 90 by 90 OD pairs to fill. This data comes from passenger surveys or from classical demand modeling. If you want to learn more about this, you can have a look in our webinars about the survey data model. Yeah, now we saw the supply and we saw the demand and how it is represented in PTV Visum. Let us now switch to the assignment. The assignment brings together the demand and the supply. It includes route search, impedance calculation, and choice. To show this, I restrict the supply to two lines, the green line and the blue line, and I run an assignment. And yeah, the results can be accessed in multiple ways. Here you can see the most common way with line bars to see how many people are using a green or the green line and the blue line. And of course, our graphical timetable could also display the amount of passengers using a special bus or train trip here as vehicle journeys. And it is now here color coded, and green means every passenger finding a seat. The volume is higher than the seating capacity when it is yellow, and red means the vehicle capacity wouldn't be sufficient for a set amount of passengers. So yeah, and if you more focused on transfers, PTV Visum have something we called a transfer display. You see this on a stop level. This is kind of a clock where arriving and departure minute are depicted in a circle segment. And this is most helpful if you want to see the transfers. And here you see maybe the minute you see here is the time of you need for transfer, and then you see you have 13 minutes of waiting time for this connection, and that many people are using this. And of course, if you have done an assignment, you can look up the demand as well in your schematic line diagram in here, and you can also depict here the transfers. Of course, these are all graphical visualizations. There is not a lot of numbers involved into this, and of course you can assess those numbers as well and have access to something we can call the network indicators, so matrices and formula matrices. In this case, I put in here the transfer time multiplied by the passengers, and you can access this for comparing scenarios afterwards. And everything I showed you before is integrated in one program, and this comes with a lot of advantages. There is synchronization between all those views. So if I click here on different several stops, the transfer display will automatically switch to the one. If I click here on journeys, you will see them in the network editor and marked here in the transfer display as well, and in the schematic line diagrams. So synchronization is one of the main advantages, but more important maybe, everything here is based on one data set. So if you change something in one view, the results will be immediately shown in the other view as well. Okay, we talked about demand, supply, and assignment. Everything like this is the passenger perspective. But Visum, as Andreas already told you, Visum also offers the operator perspective, and for this you see here the timetable, and this timetable is from the operator perspective a good timetable. You have enough preparation time for each trip, blue and the green line. But if you look up close, you will see there is an uneven number of green journeys in here. So if you see this as an operator, you know you have to have an empty trip or a dead run for in your system, and that's exactly what we can do by line blocking. We can estimate or we can calculate how many vehicles are needed to operate this timetable. And by this, you can estimate the cost of this timetable. In here, this is our line blocking editor, line blocking, or maybe you know it under the name vehicle scheduling. You see, if with 4 vehicles, you can operate this small timetable, and you see here the dead run for the green line. And of course, results like this, you can also, again, look up in your timetable to see which bus operates which journey in your timetable. Okay, and of course, if you have something like this, you have the number of vehicles, you can estimate the service mileage, of course, the empty mileage, you can estimate the service time, and of course the mileage cost, the time cost, and the vehicle costs. So you know what does it in operating cost, what is your cost for having this timetable in place. Okay, and we saw we have about 500 money units of vehicle costs in here, and I want to show you a short example of how to optimize all this. So what we see here, this is, as I already mentioned, a good timetable from operator perspective, where you have enough preparation time for each journey. But maybe if you want to transfer at this major stop Steintor here, there is a lot of waiting time involved for the passengers. And if we want to reduce this, we can change the timetable for this, the offset. And you immediately see there is something happening in our line blocking for this. And last one here. Okay, and now every trip will meet each other at Steintor, so the transfer time is minimized. And when I now rerun the procedure and the calculation, you will see, okay, I need for this now 6 vehicles. And this will, of course, bring up my vehicle cost to 750 money units. And so you see what does it cost more in operation, but as well you can look up what will it gain for the passengers. And you see, okay, there is something about 60,000 or 70,000 minutes for the passengers in your network for that amount of cost, and then you can decide is it worth to bring this to the customer to the passengers or not. So in summary, Visum do not only provide the complete set of the user perspective, but also provide multiple tools to assess the operator perspective. For optimizing your project, you have to take both into account. Okay, with this was a very, very short overview. I will hand over to Andreas to give you more insights in this.
Thank you, Sebastian. Now I need to get back to show my slides. Sebastian, can you see my slides?
Yeah.
Okay. Now we like to investigate the key 5 topics of high relevance for operators to optimize their operation for their customers and also for the whole environment. So the first topic we like to discuss with you is the strategic rolling stock investment. Then the topic of e-mobility, we like to cover the conversion of buses to electric buses. Then we will discuss how we can help to improve reliability and punctuality in the public transport system. This subject will then be followed by the design of a pedestrian-friendly station. And the final topic of this first block will look into improving fare systems. Then we will have a second block, will look into the subject of sustainability. All right, let's talk about rolling stock investment. Matching your rolling stock to your future demand is a challenge. Well, you need to find the right amount of vehicles for your rail services that makes you stay cost efficient and pleases also demand. So our customers are using PTV Visum to ensure the investment reliability by examining the optimal length of the carriages, considering also the profitability and how the vehicles will be used. Well, Sebastian, can you please provide an overview on how this works in Visum?
Yeah, SPP, the Swiss Federal Railway, as many other customers, take advantage of the line blocking, means vehicle scheduling functionality within Visum. It is integrated in a transportation model, and this enables to take the demand of the passengers into account and thus calculate the saturation of capacity in different scenarios. PTV line blocking as PTV itself is made for strategic planning. Therefore, we do not compete with tools for operational planning, which do the line blocking on a very detailed level with high demand of data. We do not touch duty rostering at all. Our approach, could you give, yeah, our approach is to do vehicle scheduling on a base of the available data in an early planning stage. So it's possible to get already good insights with just a few basic information like the timetable or the cost assumption. Our algorithms minimize the operational costs for the given timetable. The functionality is flexible enough to consider optional the demand, the vehicles available, and various other parameters. In other projects, the line blocking has been used to test and optimize the location of bus depots, for example. More information about this you can get from our webinar. I put in this QR code and we will give you afterwards the links for this. Or if you want to have some hands-on experience on line blocking, you can look up the line blocking examples within your PTV Visum installation.
Okay, thank you for this overview. As we said, it's just a quick overview of the topics, and you have the specific technical webinars to go deeper into the subject. Now we like to move to the subject of e-mobility. E-mobility can help to make our cities more livable. This accounts as well for public transport, also for private transport, and particular for new forms of mobility like ride sharing. In the terms of e-mobility, we as PTV work in many areas, also in the area of finding the optimal place for charging locations. But now we talk about public transport, and we like to focus on what is a key question for operators. So the question would be if they still can operate their network with e-buses as before. In some cases, it makes sense to redesign the network to align the routes with charging locations. Sebastian, you delivered a webinar on this topic recently. Can you please summarize the key points for our audience today?
Yes, of course. Battery electric buses do not pollute the city and they are quietly in operation, but comes with two major drawbacks. In comparison to diesel buses, their range is of course limited and the refueling lasts longer or must be done more frequently. In the EU, there is new legislation in place, and in other countries there will be something similar. The so-called Clean Vehicle Directive defines how a clean vehicle is fueled, and it gives a minimum quota on low or zero emission vehicles in procurement from summer of 20 to 21 on. So given this time windows, the operator have to plan and act now, or at least take the first steps in this planning change. And for this planning, those questions I write down here have to be answered. So which kind of system do I need? Do I need trolley buses, battery buses, or hybrid buses? Which kind of configuration for a vehicle do I need, and how many of them do I need? How many charging sites and what should be the charging power of those sites should I plan for? And yeah, do I have to really redesign my network? To answer this, could you go to the next slide, Andreas, please?
Yeah.
To answer this, we introduce the range and the charging requirements of battery electric buses into our vehicle scheduling. You see here this line blocking editor, now color coded by the charging state of a bus. And of course, a more detailed discussion, as Andreas already mentioned, and insight into these topics I have presented in this webinar, Strategic Planning for E-Buses. It is already available on the website and on YouTube, and you can also link there via this QR code.
All right, thank you. Let's move to the subject of reliability and punctuality. Well, punctuality and reliability journey times are very important for the passenger. But there's an issue. Generally, the KPIs an operator measures punctuality is based just on the timetable of trains and not on the journey time of the passenger. This could lead to many missed connections, as trains won't wait for connections passengers to just that the operator wants to meet their KPI. And it's also important to have the passenger view and gain an understanding if a train should wait or not. To optimize the reliability of passenger journeys, it's important to understand what other options are available if a connection is missed, because in some cases, well, it doesn't make a lot of sense that the train waits because there's another connection in 10 minutes available. In other cases, the passenger has to wait more than 1 hour, and therefore it's really to understand how important certain connections are and looking into the history of how reliable were these journeys. So, Sebastian, what can we do with Visum in this terms of reliability and punctuality?
Yeah, Andreas, as you say, the reliability of ride time and waiting time is an essential quality criterion for public transport, not only for trains, but as well for buses and city transportation as well. Therefore, measures to increase this reliability are important, even if they do not shorten the ride time, but only to make them more reliable. This may include timetable variants that comply with important connections and are robust against disruption, or structural measures that protect public transport from external disruptions. So measures can be expensive, or they may include buffer time in the timetable that costs the operator a lot of money. Yeah, and delays are usually not planned. They must be observed or simulated, as you already says. Information on probability of punctuality and the distribution can be easily obtained from such observations of realized journeys from ITCS data, for example. So this data can be imported and evaluated after an assignment within Visum, and a risk in minutes can be estimated to monetize from resulting delays of a connection, because we do know the connections within Visum, and so we can have this risk and the probability of its occurrence. Yeah, and if you can switch to the next slide, you can see there is an example of a bus lane which reduces the probability of punctuality, or it increases the probability of punctuality. And you see the green field is the yield from this measure. And of course, this is things these can measured be in travel minutes, and this can be monitorized, and so you can see what is the benefit of measures which do not improve the riding time, but the robustness of your timetable.
All right.
And of course, there is a short example for this via this QR code again.
Thank you, Sebastian. Okay, now talking about reliability, an operator also needs to consider pedestrian-friendly station and vehicle design. While good station and vehicle design is important for smooth movement of the passengers at transport hubs, while crowding can become an issue and lead to an unstable operation of the system, in particularly during construction periods, crowding is a very big issue. In order to create a good station design, we need to look into pedestrian engineering. And pedestrian engineering is about creating space that allows people to move freely and efficiently whilst optimizing the space available. It is about designers, architects, and engineers being able to assess and validate from the start to end of a project lifecycle how public space will work in practice for visitors, be it airports, a railway station, a sports stadium, a street crossing, all the way to a simple footpath. It is a discipline within transport engineering that focuses on the most prevalent mode of transport, it's walking. Basically, pedestrian engineering includes pedestrian simulation, and pedestrian simulation is about investigating current planning issues and getting aware of planning issues as they become apparent in a simulation. It sets the planner's mind in the right track. Our tool to simulate pedestrian movements is PTV Viswalk. PTV Viswalk is based on the social force model. The social force model calculates the force placed on a pedestrian at any given time by their desire to reach the destination and the influence of other pedestrian and barriers such as walls and buildings. PTV Viswalk can be used as a standalone product or in combination with our micro simulation software PTV Visum. Now I focus a bit directly on the station modeling. The success of public transport interchanges really relies upon fast and efficient pedestrian interchange from one form of transport to another. So with PTV Viswalk, you can accurately model the interchange between the different modes, so any change in one will affect the next one and so on. It is also relevant for evacuation planning, and since our latest version Viswalk 2020, it includes also a fire dynamic simulator. So Viswalk produces a variety of outputs such as journey and interchange times, levels of density experienced, and queuing times and queuing densities. And of course, you can make really good movies to see how the pedestrians move around the station and to see where the issues are, and to present these movies then to decision makers. For those who like to learn more about Viswalks, there are plenty of recorded webinars on YouTube available. So that's really where you can go into the details of this subject. Regarding friendly station design, I like also to mention a specific application of our real-time forecasting tool PTV Optima. It can be used to expect congestion in trains and station and help to mitigate it. So with PTV Optima, you can combine various data sources like onboard counting systems, alighting and boarding counts, data from platform cameras, data from gates, passenger travel times and pass information and vehicle positions. And the data can be used then to monitor and also to forecast the queues at the platform. So onboard crowding on the station, and you can also calculate probability in failed boarding. So this information then can be used to provide real-time information to the passengers and also to make the right decisions in your operation. So that's a tool where we are in the area of real-time information for passengers. Now I come to the last part of the first main section. It's about improving a fare system. So here in Germany, we have a strong political discussion to create a more attractive public transport system to meet climate targets, leading to a simpler tariff system. So they speak about a 365 euro ticket. So it means you just pay 365 euros a year. So basically €1 per day, and you can use the whole system, which would mean a very strong reduction in the pricing. So the responsible organizations and operators need to understand how this will impact the income. So Sebastian, what are your thoughts on improving the fare systems, and what can you do with Visum on this?
Yeah, in the last days or weeks, Luxembourg give us a good example for that. It's the first country which provides nationwide free of charge public transport. The annual cost for this is about 41 million. And of course, with PTV Visum, you can, on the one hand, model all kind of fare structures and are able to compare different fare structures with this. How to do this? You can look up again the fare example, public transport fare example within your Visum installation. But maybe more important, besides the fare modeling, it can be as well be part of the demand model. And by this, you do not only can calculate the fare income, but how people react on changing the fare. So keep in mind, it's most times not the fare that the people prevent from using the public transport. It's the supply or the service and the reliability of the system. So the cost sensitivity of passengers are not as high as the service sensitivity of the passengers. So the planners of Luxembourg are knowing this, and so a free service is not where they stop, it's where they start. And they start really to do the if you want to do to start this Verkehrswende, then you have to improve the quality, not only to make the public transport more cheaper.
Oh, thanks a lot, Sebastian. I think with these 5 topics, we really wanted to look from the operator perspective on public transport. Now we move to the next top subject, which is sustainability, which is really one key topic, and public transport plays an important role for a sustainable transport system. So here we like to broaden our perspective, and we want to look also into things like active mobility, like walking and cycling. We want to talk about the role of public transport in a multimodal transportation network, also put our view on the whole transport system and how we can make it more eco-friendly. Also, the subject of accessibility plays an important role. And at the end, we say a bit about generally expanding the public transport system. So let's start with active mobility. When we speak about public transport, we also need to consider the most important access mode, walking. But it often makes sense when we look into public transport to also consider cycling and walking. And that's not just as an access mode, but also as a mode from origin to destination. In Germany, we speak about the word Umweltverbund. This could be translated into an alliance for the environment. So improving the available infrastructure for active modes like walking and cycling is very important to shape a sustainable city. In order to increase the usage of these active modes, cities have to offer a consistent cycling and walking network. So Sebastian, how can PTV Visum help to model cycling and walking?
Visum is truly a multimodal traffic suite. So of course we support bike and pedestrian modeling with our software, and those modes are different in perspective of modeling and parameters which have to be considered. So in this active mode, or as I heard recently, the fresh air modes, the individuals and their capabilities affect their behavior more than in motorized traffic or in public transport. So personal attitudes like safety perception or fitness level or mindset steer the mode choice as well as the route choice. And this is done more than in motorized traffic. So in PTV Visum, we offer a data model which allows to include all kinds of attributes on a link or node level and include them in impedance definition. Our stochastic assignment depicts the different perceptions of those attributes by different persons. With this, we are able to calculate realistic bike scenarios and route choices. In addition to that, I do not know, do you, can you go to the next one, please, the next slide? We've done a project in Copenhagen already in 2012, and here we simulate different infrastructures and traffic engineering measures in the capital of biking, Copenhagen. So this was, of course, PTV Visum, the microscopic simulation tool to depict the realistic traffic states on planned infrastructure. And I already linked a webinar on this done last week by my colleague Marianne Petersen about modeling bike traffic in PTV Visum.
Coming back to this, it's not just cycling and walking, it's the whole multimodal transportation. With PTV's software, you can plan a holistic transport network, considering all modes of transport. In particular, the impact of new mobility solutions can be assessed. When you understand the range of results and in which assumptions have a greater or lesser influence on the outcome, stakeholders can then make important decisions with increased confidence. Sebastian, can you please elaborate on PTV Visum capabilities to model multimodal transportation and explain also how the software was developed over recent years on this?
Of course, modeling private and public transport, included bike and pedestrian traffic, is the core competence of PTV Visum. In the last years, we are working on to introduce all upcoming modes within our software solution. Those modes are often in public discussion and politics. We always try to provide a solid base of numbers and calculation for this discussion to give good base or replacing the gut feeling of politicians and decision makers by a sound foundation. yeah, we've done things for biking. In 2017, we introduced functionality to include vehicle sharing, so car and bike sharing or scooters in our traffic models. 2018, we introduced a dispatcher algorithm within PTV Visum. And now we are able to model a ride-sharing service within a macroscopic model. And this enables you to estimate the demand and, more important, to estimate the mode shift. So who are using those new modes like ride-sharing? And this gives you a clear picture of the sustainability and the sound foundation on required regulation, which might be needed. Yeah, when it comes to intermodality, so means different modes successfully used in one trip, we have improved our park and ride approach within our software, and we included vehicle and ride sharing in our timetable-based assignment to depict public transport trips using new mobility services as feeders on the last and the first mile. Could you switch to the next slide, please?
Yeah, of course, Sebastian.
There is a picture of our ride-sharing example where you see tours of, on the left side, tours of vehicles or one vehicle and their pickup and drop-off points. And of course, you can see how many vehicles are in operation right now and what kind of occupancy do they have. And you can see a link as well to our ride-sharing webinar, to explain all this functionality.
Okay, thank you very much for this. So now let's talk about the eco-friendly environment. While old school transport planning focused on providing infrastructure and services really to match the demand. But today's planning needs to focus more and more on the impacts of traffic to create an eco-friendly environment. So it's about road safety, noise reduction, air quality, environmentally friendly traffic management are key for sustainable transport planning. Demonstrating the effectiveness of strategies and measures based on a valid quantitative assessment plays a very important role in the decision-making process. And by using PTV software, you are reflecting those aspects in all strategic planning concepts. So we like to give you now a quick overview on the tools we provide on the one hand side to analyze traffic-related pollution and on the other hand side, road accidents. Sebastian, please.
Yeah, of course. Here we can offer again to watch a webinar held some weeks ago on the latest release of HB-EFA and in its integration about in PTV Visum. With this, it's possible to calculate the tailpipe emission based on volume, fleet composition, and traffic states. HB-EFA data is predefined for multiple European countries and do have a planning horizon up to 2060. The other point is safety. Here we offer the possibility to collect, visualize, and assess road accidents in our software solution. You can do black spot management, network safety management, and road safety impact assessments to forecast the service, the safety level of your infrastructure. And to get a deeper insight into this, I can as well refer to our webinar on this topic. Maybe some of you already attended this morning on our latest webinar on this topic. And tomorrow there is a chance to participate on a German session for this. If you missed the English one, it is recorded and it will be made available via YouTube as well in the next days.
All right, thank you. We also like to mention the topic of accessibility analysis, because the location of shops, schools, leisure centers is well connected to a good public transport system is really important for a livable city. So cities and communities are the center of social life and the economy. Therefore, the accessibility of the transportation is an important aspect in the quality of life. And for a city, it's important to understand the impact of, for example, closing certain areas or have less medical offices there, which applies less in cities, but more and more in rural areas, and then to still serve the communities well by the right level of public transport. By using PTV software, location analysis can inform about transportation shortages, point out action fields for a city to optimize the transportation network. So, Sebastian, how does this work?
Right. Yeah, the calculation of accessibility is most times done by travel distance or travel time. And with Visum, you can utilize the traffic model and its supply of for this calculation. So you can define the impedance on which the accessibility should be calculated. For an instance, in public transport, the amount of transfers plays a crucial role, or think about the headway. So in this screenshot, you can see an isochrone. So the lines of travel times, equivalent travel times, and this isochrone is based on a central tram station. And the color coding of the stops are not based on travel time, they are based on the transfer needed to reach this station.
All right, thanks a lot for this. Let's move to the last point, which we called expanding public transport. So at least before COVID-19 in Europe's investment in public transport and rail systems was constantly rising. And the challenge for operators is to invest in the most effective way, as they must to be profitable whilst pleasing the customers. So they are looking for a cost-benefit analysis. This is where PTV Visum performs to understand different planning case and adjusts the timetable. So Sebastian described it at the beginning of the webinar, how you can assess the cost and the passenger increases by expecting the system. Of course, this works also the other way around, and you can also plan a network with the minimum resources or how to fit with when you have only a very limited amount of passengers and you want to still have a certain service level, and how to set it up in a way to try not to lose too many passengers. Now, I like to wrap up the webinar now with an overview on the PTV functionalities, not just in Visum, give you some references, and then Sebastian will give you an outlook on the future before we answer your questions. So with this slide, I really like to wrap things up. When you start analyzing your public transport system, we can help you with PTV Visum just in analyzing your existing data. So Visum is really a good tool to bring all your data in, visualize your data, and get an overview of how things work out, how is your network, how many passengers you have on your existing lines. And then the next stage would be using the algorithms which are behind Visum to build a model, and then you can go into strategic network planning. You can then add costs to certain lines. You can add a tariff model to calculate revenue. So you have a cost and revenue calculation, which is very important for a cost benefit analysis. You could also look into your capacity of your infrastructure and see how many trains or trams are running on your tracks. Does it work when you plan your network for the next 10 or 20 years, you can use Visum to prioritize your infrastructure investment. We have briefly spoken about the strategic rolling stock investment. There's a specific webinar for it. On an example, I will also show now this point about routing and mapping and journey planner. So we also have a few real-time applications which can be used for public transport management, and also the real-time passenger predictions, which I described for in terms of designing stations. And yeah, the last point here is the station design. So I will follow up with 3 examples of key clients we are looking after. So one of our key clients using our software for public transport planning is BVG, so the transport operator in Berlin. They used PTV Visum to plan new infrastructure for Berlin's underground and tram network. They also analyze the whole city to see what is the proportion of passengers they already have, where they maybe it's possible to win more passengers. And 2 years ago, we also applied a new application of our software, the PTV Mass Modeler, to introduce Bergkönig, which is a on-demand ride-sharing service in Berlin. Now I move to the Swiss Railway, which was already mentioned in this webinar, as they use our software for the strategic investment of rolling stock. But they do much more with our software. They use it for the timetable planning, so they finalize the timetable. They use the schematic line diagram Sebastian presented at the beginning of this webinar. They also use our software to model the demand over the whole course of the day, so not just an average hour of the day, but really how the demand changes during the course of the day. And now they are working towards a new application in terms of the strategic investment of rolling stocks, that they also consider now the maintenance intervals for their vehicles, and they use it for the software PTV with Walk for their station design. Now, one of really the key clients here in Germany is the Deutsche Bahn. They have about 100 licenses of PTV Visum. They also do station design with our software in different used in different departments. So one key application is the long-term planning of new concepts of Deutsche Bahn, but a quite interesting usage of Deutsche Bahn is also a short-term forecast based on the daily ticket sales. So they do a forecast for the next day where they put in all the ticket sales information they have, and basically there are most of the tickets they know from where to where the people go, but there's some season ticket holders, and they basically use our software to fill the gaps for the daily forecast. Also, an application which was mentioned is basically to make their timetable more robust in using these punctuality assessment we have talked about at the beginning of the webinar. And one thing I haven't mentioned yet, but especially for people from Germany who are listening to this webinar, they might have used it already. It's a real-time application. So as part of the rail journey planner, the DB Navigator, which is, I think, one of the most used apps in Germany, our PTVX server is included. And this is a journey planner which is based on mapping and routing, and it's included in their app, and it provides information and maps for the planning of journeys. So I like now to hand over to Sebastian to give you an outlook, and please use the time now to ask questions. In the meantime, while Sebastian gives you an overview of the outlook, I will summarize the question, and then we want to answer them together. So, Sebastian, can you take over, please?
Yeah, hopefully you see my screen now. Do you?
Yeah. Yeah.
Okay, perfect. Perfect. Yeah, we of course continually try to improve and extend our software. So I can give you some topics we are right now working on. So it's a kind of an outlook or what our visions are for PTV Visum or our PTV Vision Suite in the next year. We want to extend our crowding functionalities in PTV Visum for public transport assignment. So think about how to, if the capacity is not sufficient on trains or buses, this fail to board for passengers, how can this be applied in an assignment? We want to have more improvements on intermodal connections, so on ride sharing and public transport for these feeder modes on first and last miles. We want to cover new directives on an environment prevention, noise prevention, so environmental directives. We want to think about public transport functionalities, something in the loop. So we will connect to some operator tools with some partners there over standard interfaces. So bringing together those operating world with the strategic planning world. We are working on something we called Vision Web. It's kind of web-based publishing for Visum results for non-modeling experts. So giving the access for this valuable data to people who do not touch Visum regularly. We have tried out things for Visum AR. AR is augmented reality. It's a very, very nice way to present Visum results. This gives you the chance to use your mobile phone to watch Visum scenarios live on a map, which is on the table before you, so everyone could have another perspective to on this Visum scenario to see the results. And of course, as other companies, we also find out how to utilize MDS, so mobility data specification data. So those topics are just some of many, but yeah, of course, as always at this point, if you have ideas or needs what should be included in our software, something what would improve your daily work, please let us know. We are always happy to receive ideas for new developments. Yeah, and speaking of development, PTV is, of course, a software company. But we do not only develop software. If you are stuck in our software somewhere and need some assistance, we offer several services to get you back on track. So what you see here is our start page of PTV Visum, and for PTV Visum it looks similar for Vistro itself also. From here you can be directed to different very helpful links, and let me use this occasion to point you to this. You see here support services, and first one you see maybe our release notes. These are always comes with the installation, and they gives you the difference between the last and forelast versions. So it's kind of our work log we're doing in development. We provide a very extensive online help, a manual, which contains two parts. The fundamentals, which gives you the theoretical framework. And with this, we want to prevent that our software is a black box, so everyone can see how we calculate things. And of course, there is this very useful user guide to explain the meaning of each button and parameter. One of our greatest sources of information, if you want to really model, to have a hands-on examples, are our examples. So if you want to model this or that, you can find the main use cases in our software summarized in those step-to-step tutorials. And of course, we receive questions from your end, and things we have been asked before are summarized in our FAQs. Also a good site to receive answers. And I mentioned this a few times today, our webinar archive. This gives you an introduction and insights in our software and their use cases. And all of them are available free on our website or on YouTube as well. And of course, we do have technical support. So if you are stuck somewhere in our software or experience an unexpected behavior of our software, there are really passionate people at PTV to help you. You can fill out this form and you will get an answer from people working for us, helping you within PTV Visum. And of course, the training department, if you are new at our software or want to dive into a new field of application, PTV offers frequently classroom trainings all over the world in different languages. Just please pick one appropriate to your knowledge level and join them. If you have a topic not covered here, PTV is also offering on-the-job trainings where trainers are visiting your site and helping you starting your projects. So maybe in summary, please let us know what we can do for you and where we can help you. Yeah, thank you. And now, Andreas, what about the questions?
Yeah, let's move to the questions. Please feel free also to ask further questions. So far, we had a few questions regarding e-mobility, and specifically, yeah, what can we do about e-bikes, e-scooters? Do you want to say something about this, Sebastian?
Okay, yeah, e-bikes and e-scooters, I would think, okay, if it's privately used e-bikes and e-scooters, they are kind of bikes, so it's kind of how to model and how to set up your system and how to assign them. If you think about them as mobility as a service, so there is a provider and you rent those e-bikes and e-scooters. We provide an extension of our timetable-based assignment called vehicle scheduling for exactly this, bike sharing and vehicle sharing. This is as well true for e-scooters and e-bikes, of course. And this can be modeled within public transport assignment.
Yeah, and I think where we can also help with questions in regarding where you will place your e-scooters and where you have your charging locations, everything which is based on demand. And it's also with our tools, we can visualize data from e-scooter providers, which we actually did in a certain project, and analyze where these e-scooters are and match these with other data. So there are, on the one hand side, few, let's say, it general modeling tools where you say, well, e-scooters or e-bikes is just another mode and it doesn't behave in a complete different way. And on the other hand, you have questions specifically asked by e-scooter or e-bikes provider how to set up the system. And I think with our software, we can help there in many ways. Or do you want to add anything on this, Sebastian?
No, it's fine. Good.
Okay, now lots of questions coming in. I think I saw one. I want to know more about modeling bike traffic. Where can I find information, videos about this? So we have this German webinar you mentioned.
Right now.
Do we have anything in English on this?
Not yet, but it is planned to do a bike modeling example. A Visum example, really to hands-on how to model this. And we will have an eye on how many requests we will get from a bike modeling webinar. Maybe we can ask for doing this in English as well. Yeah. Not sure about yet, but yeah, if it's asked for, we could do this.
Yeah. Maybe in terms of bike modeling, especially in Germany, we see a strong move to do more bike modeling. And I think the key is really having the data, and to include it sensibly in a model, you really need to do a proper bike survey. So far, often in models, it was just taken into account in the demand model. But nowadays, we more and more set up really are also assignment models. And then the other thing in terms of looking into cycling facilities, you can use PTV Visum and PTV Viswalk for looking into this in detail. So let's go further. Can we have PTV for freight management, route optimization, and reduction in freight cost? Do you know anything about freight? Maybe it would make sense to look at our logistic guys could help there, or we have also the freight model in Visum, but I think that's two different areas.
There's two different things. I think so the question here is more on the operational perspective on this, and yeah, PTV offers a lot of things there. But by our colleagues from the transport department. So yeah.
Maybe I can add something. Sorry, this is Anna speaking. I know that there's a second webinar series planned. Our colleagues are working on that, the co-workers. So if you just have a look at our channels and pages, I'm sure you're going to find one, and I'm going to take your idea and gonna drop it in the logistics team. So just be a little bit patient and we keep you posted.
Okay, thanks a lot for this. And we have a question regarding what is the best way to import a large public transport network into Visum. What is the best things to start with? I think it doesn't make sense to put in everything in manually. Perhaps you can give a few ideas what is the best data sources PTV Visum can read, and maybe we have also some webinars which help you to show you how to do it in step by step.
Right. Right. We provide webinars on this, and we have a full stack of standard interfaces. Maybe one of the famous one is, of course, GTFS. So if you do have GTFS data, you can immediately import this into Visum. And as well, we do have functionality of map matching them to your existing model in a second step to keep them up to date, to your model up to date without affecting your changes you have done before. So yeah, there are webinars on this. I think this is the title is very similar how to import public transport data within Visum. So, and of course, for if it comes on operational tooling systems, we do provide the most common interfaces like HAFAs, like VDV 452, and so on. It depends a little bit on what kind of nationwide standards you see and you have.
All right, thanks a lot. Now we have a quite technical question. Not sure if you are able to answer it, but do you know, Sebastian, things about the line blocking algorithm? Which algorithm is used there?
Yeah, it's kind of a graph method within there, and we use a generic algorithm a short step behind. So we build up graphs which determines the best solution. The best solution is by a definition of cost function you can define, and because you can't solve this problem by just calculating, it's NP hard. So this means you need an algorithm or a genetic algorithm which tries out several scenarios and always picks the best ones and the best part of it and combine them afterwards. If you are especially interested into this algorithm, there is a chapter of it written in the manual, and there is a paper published on this, and we've done some extensions for this year for electric buses, battery electric buses, and this was presented at TRB this year. So if you get in touch with us, we can point you to these papers and give you a deep insight into these algorithms.
Yeah, maybe it makes to have a list of the relevant webinars and also of the relevant papers linking to these questions, because one of the final question was also how to access these webinars, which works with a QR code. You put your mobile phone next to the slide, and then it opens up the webinar in YouTube, but we can make a list with a direct link to it. Okay, now let's see if there are more questions which we can answer. Okay, can you talk a bit about the capacity constraint model in the headway-based assignment. Apparently it uses a few sets of Python codes, and there's no information on how to edit these Python codes and changing the calibrated values. Do you know anything about this?
Yeah, I know about the example. There is an example about capacity constraint assignment for a headway-based assignment. But yeah, and it is script-based, and the scripts are delivered within these within the installation, so you shouldn't have any problem to access this. If you have questions about this, and maybe if you do not find those the scripts, yeah, please get in direct contact to us. We can show you and we can help you there.
Then we have a question which I think is less technical. It's more about what is the situation now in Germany with the 365 euro ticket, and this would be very important to move forward with the changes in public transport. So I could add to this what I see really from the political side, that a lot of politicians really want to push for it, but what we see it as PTV is that it's very important to look deeper into it and analyze it in detail, what you really need to improve your public transport system. And it's often not the price, it's really the quality. And I think Vienna, who started with this 365 euro ticket, was very successful, and a lot of politicians look at this city, but they did first basically improve the system, and then they put in the 365 euro ticket. And I'm a bit afraid now with politicians, they're really pushing for it because they want to show that they can do something quickly. But on the other hand side, it's very important really to improve the system, and with Visum you can do a detailed analysis what helps you to improve the system, and also how many additional passengers you win with different ticket pricing, and also how much money you lose with it. I think that's an important thing to look into it. Do you want to add anything on this, Sebastian?
No, exactly what I would have answered.
Then okay, could we simulate exported public transport network from Visum in Visum software? I think that's not a straightforward thing. You need to set up a new timetable in Visum, or what are the possibilities there?
It's possible. It's possible. We can use our ANM format, so you can go to Visum, bring up your public transport service in there, use a timetable, and then you can export those to ANM and import this in Visum. And of course, the approach is a little bit different there. In Visum, you will get something like, of course, the stops and the departure time for the buses, and really the travel time. Of course, this depends on the Visum simulation then. So if your bus is stuck in traffic, that's exactly what you can simulate within Visum, not in Visum. So this is microscopic. So the travel time is not for buses. It's not in the timetable for Visum. It is more a result from Visum. But of course, you've got the different departure times at the stops, which can be included or imported from Visum.
All right. Well, I think we got through now most of the relevant questions. From my side, really thank you for your time, and well, stay healthy and all the best to get through these challenging times.